So good day, ma'am. Good day, everyone. We are the group 4, Gaas, Gagliarde, Maude, Morato, and Villanueva, and we are tasked to discuss about the preparation and standardization of silver nitrate solution. And unfortunately, we weren't able to accomplish the said laboratory activity due to lack of materials. But today we will discuss about only the principles of preparation and standardization of silver nitrate solution. And for our objectives, first is to calculate the normality of silver nitrate. Second is to compute for the average normality of trials 1 and 2 in standardizing silver nitrate solution. And lastly, to compare the computed values to the theoretical normality of silver nitrate. And we were able to accomplish these said objectives, but the data and results we have used in this reporting are solely based on the samples of data and results from an online reference with the same procedures as presented in this laboratory activity. And for the materials involved in this experiment, we have our silver nitrate as our titrant, which is placed inside the burette, and the sodium chloride as our analyte, and 0.1 m of potassium chromate as our indicator. For a short introduction of this laboratory experiment, first off, the preparation and standardization of silver nitrate utilizes a volumetric method, which is based upon the formation of sparingly soluble precipitate, which the name suggests precipitation titration. It is a type of titrimetric procedure that involves the formation of precipitates during the course of titration. And the titrant reacts with the analyte, forming an insoluble material, and the titration continues till the very last amount of analyte is consumed. The first drop of titrant in excess will react with an indicator, resulting in a color change and announcing the termination of the titration. So in our case, the brick red precipitate, or the silver chromate brick red precipitate, is our endpoint. And here we have presented the key points or summary of the methods used in this laboratory activity. First is that it is a type of volumetric analysis that depends on the formation of the precipitate. And second, it is the most important precipitating agent used in the precipitation titration is silver nitrate, which is our titrant in this laboratory activity. And lastly, titrimetric methods based upon using silver nitrate solution are called argentometric titration, which is mainly used for the determination of halides or the elements within the group 7 in the periodic table, which is our chloride ions, bromine, and the iodine.
So here, precipitation titration are based upon reaction that yield ionic compounds of limited solubility. Titrimetric methods based upon silver nitrate are sometimes termed argentometric methods. Potassium chromate can serve as an endpoint indicator for the argentometric determination of chloride, bromide, and cyanide ions by reacting with silver ions to form a brick red silver chromate precipitate in the equivalence point region. So dito, yung precipitation titration natin, yan yung common na analytical technique na nag-rely siya sa reaction na napoproduce ng ionic compounds natin with limited solubility. So one common na mga indicator na use dito is yung potassium, kasi yung potassium chromate is nagre-react siya with silver ions para maka-form siya ng brick red precipitate. And yung indicator na ito, it is particularly useful sa argentometric determinations natin. Kasi na-monitor niya yung formation ng mga precipitate, tapos mas mapadali and ma-determine yung mga concentration ng mga target ions sa solution. Next slide. silver nitrate standard solution. After all the chloride has been precipitated as white silver, there's excess of titrant result in silver chromate precipitate, which signals the endpoint. The reaction are, ang reaction natin is Ag plus or silver cation plus i-plus natin siya with chloride ion. Yung product na mapoproduce niya is silver chloride. Next is 2Ag plus plus CrO4. Yung product na mapoproduce is Ag2CrO4 or also known as silver chromate. Tapos, dito din is yung sa first na reaction, dito na-form yung white precipitate. Tapos, sa second naman reaction is maka-form siya ng brick red silver chromate precipitate, and dito din yung endpoint ng titration.
So next, the reactions involved. So the precipitation titration use a formation of a precipitate, usually with a unique color, para ma-indicate ang endpoints ato ang titration. So here, we use the Moore method where it aims to quantify the concentration of chloride ions in a given solution. So these methods involve dispensing the solution of silver nitrate, which is ang ato ang titrant from the burette, into the flask na which contains the chloride ions, which is ang ato ang analyte that we want to analyze. The flask also contains some amount of potassium chromate, which is the indicator of this titration. So mag-start ang reaction pag ang stopcock sa burette is open. So the silver ions will start to react with the chloride ions para maka-form og white precipitate, and that is the silver chloride. So as we can see here sa reaction, silver nitrate plus sodium chloride to form silver chloride, which is ang white precipitate. So pwede ko pa next slide, kadali lang siya. So as we can see from the initial, nag-form siya ng silver chloride, which is yung sa second picture, meron siyang white precipitate. So next ay pabalik na po ko siya. So it is important na mag-add ta og silver nitrate in excess so that katong tanan na chloride ions sa solution are precipitated. So when all chloride ions are reacted, so katong excess amount sa silver ions na excess react na sa please napud ko sharp balik sa okay, so as we can see in the third picture, nag-produce siya precipitate, but this time the precipitate has distinct reddish brown color. So pag ma-observe na nato ni na precipitate, mo na ni ang sign na i-close na nato ang stopcock sa burette para i-stop na tong addition sa silver nitrate. So the formation of silver chromate precipitate is used as an endpoint of this precipitation titration method. So we have two key concepts to take away from Moore's method. So first is that silver ions only react with chromate ions when all the chloride ions in the solution have already precipitated. And this is only made possible because silver ions preferentially precipitate with chloride ions over chromate ions. Why? So as far as I remember sa na-discuss sa lecture, it is due to the relative higher solubility of silver chromate compared to silver chloride. Also, this is because the formation of silver chloride results in a greater decrease in the concentration of silver ions in solution compared sa formation sa silver chromate. Second, in a number of moles of chloride ions in the solution, it is equals to the number of moles of silver ions due to the 1:1 stoichiometric ratio in the precipitation reaction.
And now, let us proceed sa sample data and results for solving the normality of silver nitrate. So, here are the results na na-gather po namin pero from the online references lang po. Trial number 1 sa weight po ng potassium chloride namin, sodium chloride namin is 0.20 grams. Sa trial number 2 is 0.25 grams. Then sa final reading ng trial number 1 is 20.20 ml. Then sa trial number 2 is 30.40 ml. Then for the initial reading ng silver nitrate is 10.15 ml, then 20.20 ml naman sa trial number 2. And for the volume of our silver nitrate used is sa trial number 1 is 10.05, then sa trial number 2 is 10.2 ml. Then sa normality, sa pag-solve po namin, ang nakuha namin is 0.12 sa trial number 1 and sa trial number 2 is 0.14. Then the average normality is 0.13 N. So sa next page po is makikita natin kung paano i-calculate yung normality ng each trials. So dito, kinuha muna natin yung molecular weight ng silver nitrate, which is 170 gram per mole. Then, after is, lahat ng yon is ginamit natin para makuha natin si MEQ. Then, after getting the MEQ is mag-proceed na tayo sa normality. Pagkuha ng normality for our trial number 1 sa silver nitrate. Then, after is, ito na ang nag-gather natin na data, which is 0.11, 70, 61, 7501 N. Then kung round off natin is 0.12. Then for trial number 2, same lang sa trial number 1 na ginawa natin. Then ang nag-gather talaga namin ang na-solve namin or na-calculate namin na data is 0.14, 41, 75, 31, 72. Then kung i-round off natin siya is 0.14. Dito sa average normality is kumbaga i-add muna natin yung trial number 1 and trial number 2 na normality. Then i-divide lang natin siya sa 2. Then ang nakuha is 0.13 N. So dito, ito po yung reference namin for our trial number 1 and 2 na nakuha po namin sa aming source. Po.
For the theoretical reference for the normality of AGNO3 or the silver nitrate. So to calculate the normality of the silver nitrate, you need to know the molarity of the equivalent. Since it's a number of equivalents is equal to its molarity. Therefore, the normality N is equivalent to the molarity M. 0.1 M solution of silver nitrate is equivalent to a normality of 0.1 N. So when we say normality and molarity, di ba, there are both measurements na para ma-calculate natin ang concentrations of the solution. In the case of silver nitrate, since di ba dito na monoprotic acid siya, meaning ang each molecule daw of the silver nitrate pwede siyang mag-donate ng 1 proton when it dissolves in the water. So for mga monoprotic acids like the silver nitrate, ang number of equivalents niya is equal to its molarity. So meaning for every 1 mole daw ng silver nitrate na ma-dissolve, meron kang makuha na or it is equivalent to 1 silver ions na available in the solution. So to find the normality of the silver nitrate, you simply use lang the molarity because because it is monoprotic. So in short, ang mga monoprotic acids like the silver nitrate, ang normality niya is same lang sa molarity since each molecule man is nag-provide ng 1 equivalent of ions when it is dissolved. So ang 0.1 M of silver nitrate is equivalent to a normality of 0.1 N. And for our conclusions, The objective of the experiment was to standardize silver nitrate solution through titration with NaCl as the analyte and potassium chromate as the indicator. Students aimed to calculate the normality of silver nitrate, compute the average normality from two trials, and compare the obtained values with the theoretical normality. Due to the unavailability of silver nitrate, students relied on researching information and sample data to fulfill the objectives. Despite the students' efforts, the unavailability of silver nitrate posed a significant challenge, limiting their ability to conduct practical experiments and gather first-hand data. Instead, students had to rely solely on secondary sources for information and sample data, making it difficult to verify the accuracy and reliability of the obtained results. Based on the sample data and results, the normality of silver nitrate has an average normality of 0.13 N, which corroborates the theoretical reference indicated in this report. This lack direct experimentation may have contributed to the unsuccessful gathering of accurate data and results. Despite the absence of practical experimentation, students were able to of silver nitrate solution through research and theoretical exploration. Titration and factors influencing the accuracy of results, students gained insight into the complexities of analytical chemistry techniques.